This is like a problem where we've already completed the square on the left-hand side, and so now we need to finish it by taking the square root of both sides, which undoes squaring. And when we take the square root of both sides, there's a missing solution that we can discover by putting a plus or minus in front of the number. That allows us to call the square root of x minus 3 squared x minus 3. We can add 3 to both sides. When you add 3 to both sides, be sure and put the 3 in front of the plus minus sign. Now this is two possibilities, x equals 3 plus 4 or x equals 3 minus 4. That's what this plus or minus means. X equals 7 or x equals -1. This is not a case where you need to check your solutions. These should both work if our work is correct. Notice if we did try to check the solutions, if you put in 7, you get 7 minus 3 quantity squared equals 16, which is true. And if you put in -1, you get -1 minus 3 quantity squared equals 16, which is true. This is 4 squared, and this is -4 times -4, which is also positive 16. So the check is not mandatory, but the check is certainly doable. Here, once again, we're going to take the square root of both sides to undo the squaring. When we do that, we need to put a plus or minus in front of the square root. That allows us to write x plus 1 on the left, and we have plus or minus. And this is the square root of 9 times I. That's what the square root of -9 is. We call it the square root of 9 times the square root of I, which is 3i. So we have x plus 1 equals plus or minus 3i. We're going to take 1 away from both sides, and we have x equals -1 plus or minus 3i. Those are two solutions. X equals -1 plus 3i, or x equals -1 minus 3i. These two solutions do not need to be checked, but they do check. So for instance, if I want to check this one, I could go to the original problem and replace x with -1 plus 3i, and then I'd have plus 1 squared is supposed to equal -9. I've copied the original equation, and I've put in the first value for x. This -1 and that +1 cancel, so I'm left with supposedly 3i. The entire quantity to the second power is supposed to be -9. But this is 3i times 3i, which is 9i squared, which is -9. It checks. Both of these solutions would check, but it's not a mandatory check. On this problem, since there isn't any way to simplify these, it would be acceptable to leave both answers in this form. We're asked to complete the square. One way to do that is to get the number on the other side by subtracting 32 from both sides, and then to figure out what goes here so that this trinomial will be a perfect square. And it's always half of this times itself. So start with 12, the coefficient of the x, take half of it, and then multiply that by itself. So it's half of it times itself. It's 6 times 6. We're going to add 36 to both sides. Over here we get 4. Over here we get x plus 6 times x plus 6. It's a perfect square. It's x plus 6 squared, which equals 4. And now we can take the square root of both sides and put a plus or minus in, just like the previous few problems. We have x plus 6 equals plus or minus 2, taking away 6 from both sides. We have x equals -6 plus or minus 2. That is x equals -6 plus 2, which is -4, or x equals -6 minus 2, which is -8. These are the two solutions. They should check in the original problem. I'm going to check them by just looking. -4 checks, -8 checks. So these both do check if you were to try them in the original equation, but they are the solutions. We've done it by completing the square. In a similar fashion, we're going to add 3 to both sides. Then we're going to complete the square. We look at this number, we take half of it, and we multiply that by itself. So 16 is the number we need to add to both sides. Here we get t plus 4 times t plus 4, which is a perfect square. Here we get 19. T plus 4 squared equals 19. Now we take the square root of both sides. We get t plus 4 here equals plus or minus the square root of 19. Square root of 19 does not simplify. There's no factors hiding in there, so we just take away 4 from both sides, and we have t equals negative 4 plus or minus the square root of 19. You can write out the solution separately as t equals negative 4 plus the square root of 19, or t equals negative 4 minus the square root of 19. Or, since there was no simplification, it's possible just to leave both answers in one nice, compact form. And we're done.